Greetings! This launches a new YouTube channel devoted to comets and other small bodies of the solar system, especially objects that may be related to comets such as meteors, interesting minor planets in comet-like orbits, including trans-Neptunian objects, and natural objects orbiting the Sun that come very close to the Earth. Some videos will touch on spacecraft missions to small solar system bodies and eclipses. Our intention is to produce a regular series of videos to discuss what's in the news regarding comets and other small bodies of the solar system, particularly objects that may be observable with small telescopes, binoculars, or even via naked eye. We will produce both short videos for the general public and longer videos for experienced observers and enthusiasts. Who is we? We are the longtime editorial staff of the International Comet Quarterly, also known as the ICQ, which is a publication started in 1978 at Appalachian State University in Boone, North Carolina, and published for decades at the Smithsonian Astrophysical Observatory, abbreviated SAO, in Cambridge, Massachusetts, under the principal editorship of myself, Daniel Green. This first video is an introduction video for those new to our channel and who want to know more about who is creating the material in our videos. The ICQ was started as a way to archive international physical data on comets, especially standardized data on the brightness and sizes of comets, and also to publish news regarding new comet discoveries and analyses of the comet observations as a way to bridge the work of amateur and professional astronomers. The ICQ thus created a printed and digital archive of comet data from the beginning, and it also began organizing so-called international workshops on cometary astronomy in the 1980s that continue to this day as a medium to bring professional and amateur astronomers together to coordinate observing and analyses. The ICQ has long published an annual comet handbook that gives updated information on comets, including orbital data and ephemerides, which are tables predicting where comets will appear on the sky as a function of date and observability, with careful predictions of brightness. Some 15 years ago, the ICQ began developing a project to expand archiving of data to include imaging and photography of comets. We now have an ICQ forum page on Facebook known as ICQ Comet Observations, which contains many posts daily from experienced observers of comets, including photographic images of comets ranging from naked eye comets to very faint comets. We have been establishing standards for people posting images of comets on the ICQ's Facebook page, as we are archiving all of the observations posted there for display on the ICQ's own computer servers. This channel is being co-hosted by Charles Morris of Fillmore, California, who has been associate editor of the ICQ since 1978, and by Carl Hergenroether of Tucson, Arizona, who has been an associate editor for a quarter century. Together, we have over 130 years of combined observing experience with comets. I'll briefly introduce myself, and then I'll let Charles and Carl introduce themselves. Since 2010, I have been a research astronomer in the Department of Earth and Planetary Sciences at Harvard University, which also hosts computer servers that have been generously bought with funding from the Tamkin Foundation in California. Prior to being in the EPS department, I was at SAO for more than 30 years as a research astronomer there. I have been director of the Central Bureau for Astronomical Telegrams, abbreviated CBAT, since 2000 and served as assistant and associate director of CBAT for some 20 years before that. The CBAT has announced new discoveries of comets and other celestial objects since its creation in 1883 in Kiel, Germany, and continues its focus on announcing news of small solar system objects. I also sit on the working group for small bodies nomenclature of the International Astronomical Union, which is tasked with the naming of new comets and of minor planets with well-determined orbits. I'll now turn to Carl Hergenroether to introduce himself. Carl?
Thank you, Dan. Hello, everyone. My name is Carl Hergenroether. My interest in comets probably began in the basement of my childhood home in northern New Jersey. My dad had a large collection of books on a whole range of subjects, from history to planes, trains, and automobiles. For whatever reason, it was the astronomy books that really piqued my interest, and in particular, my interest in comets. I must have read and reread the Comets chapter in the National Geographic Our Universe book 100 times. So even from a young age, I had an interest in comets, though it would be years before I would ever actually see one. I was born too late to have seen the great comets of the 60s and 70s. The first comet I ever saw was Halley back on November 1985, through my dad's late 50s era 60mm refractor. First I found the Pleiades, and then after a little searching I found Halley. It was only the second time I had ever looked through a telescope, and the first time I had used one all by myself. A few years later, I'd observed my second comet with the 60mm, Comet Bradfield, in 1987. In the spring of '89, I turned 16, and for my birthday I received my first upgrade in aperture, a Meade 6-inch Schmidt-Newtonian. With this telescope and my handy Star Atlas 2000 and Uranometria 2000 atlases, I really learned how to observe and navigate the night sky. More or less around the same time, I got a subscription to Sky and Telescope. Within its pages, I learned about and then joined organizations like the Association of Lunar and Planetary Observers and the International Comet Quarterly, and so began my career of recording and submitting comet observations such as magnitude estimates and drawings, starting with the return that summer of Comet 23P Boursin-Metcalf. For my undergrad studies, I moved out to Tucson, Arizona to attend the University of Arizona. It was there that I teamed up with Steve Larson and Tim Spar, first to study comets and then to hunt for new comets and asteroids. While originally a photographic survey, our effort eventually grew into the CCD-equipped Catalina Sky Survey, which is still going strong today. That's me in the baseball cap with Tim in the top left image, and with the rest of the then Catalina team in the lower left image. Surveying was fun, and you never knew what you would find on any given night. During my time there, I discovered numerous asteroids. One such discovery even got our picture in Time magazine. I also discovered 4 comets at the survey, 3 of which bear my name. The first discovery in 1996 was a photographic find, while the other 3 were discovered with a CCD. I am proud to say that I was able to observe 3 of my 4 finds visually, though I had to cheat and use a 61-inch telescope for one of them. Unfortunately, Comet 168P failed to return at its last perihelion and may have completely disintegrated. After my time at Catalina, I spent less time researching comets and mainly focused on near-Earth asteroids, in particular the study of the smallest and fastest rotating asteroids. That work eventually led to my becoming part of the NASA University of Arizona OSIRIS-REx spacecraft mission to collect a sample from the carbonaceous near-Earth asteroid Bennu. I had a bunch of different jobs on OSIRIS-REx, including being part of the observation planning team, selecting the target, heading the characterization effort, and upon arrival at the asteroid, leading the astronomy science working group responsible for searching for any hazards that might be around Bennu, like say cometary activity or large satellites. While I didn't find any activity or large satellites, my biggest contribution to the mission was the discovery that small particles were being routinely ejected from the surface of Bennu. Not quite cometary activity and not quite satellites, but something in between and definitely something new. After collecting its sample of Bennu in 2020, the spacecraft has now departed the asteroid. Likewise, I have also departed the University of Arizona after almost 30 years to work at a new small company called Ascending Node Technologies, where we consult on other spacecraft missions and develop mission support software. Though I no longer do much professional observing these days, I'm still observing comets and other objects from my backyard as well as remotely. Visually, I mainly observe with binoculars, including my big 30 by 125s. For imaging, I currently use a small Astrotech 72mm refractor and an ASI 183 monochrome camera from my backyard. For remote imaging, I use the telescopes hosted by iTelescopes and SkyGEMS Observatory. In addition to my work at the International Comet Quarterly, I am serving as the Comet Section Coordinator and Executive Director of the Association of Lunar and Planetary Observers. Both the ICQ and ALPO were 2 of the organizations I joined back in 1990 when I was still in high school, flipping through those old pages of Sky and Telescope.
Hi, I'm Charles Morris, and this is my life story as a comet observer. I observed my first comet in 1968. It was 1967 Y1, a Kiyosaki, not the bright Kiyosaki, but the fainter one that occurred several years later. Over my lifetime, I've observed over 300 comets visually, mostly with a 25 centimeter reflector obtained in 1984 and a 50 centimeter reflector obtained in 1988. Prior to that, I used a home-built 15 centimeter reflector and a different 25 centimeter reflector. I published my first professional paper when I was at college in 1973. It was on 1967 Y1 and Kiyosaki. It was co-authored by John Bortle. I published my second professional paper in the same year on aperture correction. That is a correction that is needed when large apertures are used to make visual comet magnitude estimates. In all, I've published about 100 papers, mostly on comets, but also on BE stars, tornadoes, and satellite remote sensing. For 22 years, I worked at the Jet Propulsion Laboratory on satellites that look down at the Earth. From 1978 on, I have been the associate editor of the International Comet Quarterly, working closely with Dan Green. I hosted the Comet Observation homepage at JPL, the Jet Propulsion Laboratory, from 1995 to 2005, and then at Meade from 2005 to 2007. Scott Roberts, then vice president of Meade, was nice enough to arrange that hosting. Unfortunately, when Scott left to start his own company, Meade abruptly and without warning terminated the website. I started CCD imaging of comets in 2000 with my 41 centimeter f10 Schmidt-Cassegrain telescope. The focal ratio was reduced to f6 with a focal reducer. Prior to that, I had learned how to do CCD observing using the telescope in education's telescope at Mount Wilson. It was a 24-inch telescope, but I never imaged comets there. From 2006 to 2018, I took a hiatus from comet work because my wife Carmelita and I started our own business, and there simply was not enough time to do anything other than the business. In 2014, Carmelita, my wife, partner, and fellow astronomer, passed away from cancer. And it took several years after that before I renewed my interest in astronomy and doing comet work. In 2018, I resumed comet work and imaging. My current system is the same 41 centimeter Schmidt-Cassegrain telescope, now f6.8 with a new CCD. It can image comets down to 18th magnitude. This is my observatory and my house in Fillmore, California. The observatory is located at approximately 34 degrees north and at an elevation of only 150 meters above sea level. It is located about 25 miles from the Pacific Ocean, and that location, unfortunately, impacts my observing sometimes with low clouds and fog. This is me with my 41 centimeter telescope. The CCD that I use peaks in the visual. The image scale on the images is 22 arc minutes by 17 arc minutes. Here's a couple of examples of comets I've imaged. This is 2020 F3 when it was quite bright. You can get an idea of the image scale. again 22 arc minutes by 17 arc minutes. The streaks are stars the comet was moving. This is a more recent comet, 2022 E3. It is projected to be modestly bright at the beginning of next year, but right now, at this point, it was 14.6 magnitude. It's the small dot in the center, and there's a tail extending downward. And that wraps up my segment.